Okay guys, it's time to start chapter 11, logarithms. Fun stuff. So first we'll start with an intro to logarithms. Alright, so the idea is, let's see, so big one, we'll just say logarithms and we'll have a bunch of notes today. Logarithms, so little a, what the hell is a logarithm? Well, the idea is to solve something, to solve an exponential equation, something like 10 to the t equals 4,000. The way we did this in chapter 10 was we used tables and graphs. So we used tables and graphs in chapter 10. All right, but that takes technology and a lot of work. So now we want to figure out a way to solve these algebraically. So to solve these things algebraically, we're going to use something called a logarithm. So to solve algebraically, use a logarithm. All right, so let's see exactly how we set these up. So little b, let's see. So the idea is, here we're going to, in this section, we're going to use the common logarithm. And this is just for now. There are many, many logarithms, but in this section we're just going to use one, and the common logarithm is simply log base 10 with an input of x. All right, so this is a subscript here, so you have to write it low. So here's the subscript, and this is your input of the function. So a logarithm is a function, and the base on the logarithm is written as a subscript, and then you have the argument. All right, but what we do is, since this is the common logarithm, we're going to write it without the base. So anytime you see log of x, the base equals 10. Okay, so let's think about a couple of these things. So basically, these are very, very simple. You just have to wrap your head around it. So if I write log of x, this is asking a very simple question. What is the power we raise 10 by to get x? All right, so the logarithm is always asking for an exponent. So this log of x is an exponent. So we got to keep that in mind. So let's see. So little 2. If I say log of 100 equals what? Well, you have to think. 10 raised to what power equals 100? Well, we should all know the answer to that is 2. So the answer here is 2. So log of 100 is 2 because 10 squared is 100. Okay, let's try another one. How about log of 1,000? What does log of 1,000 equal? Well, think about it. That's asking 10 to what power equals 1,000? Well, you guys should know that the answer to that is 3. So log of 1,000 equals 3 because 10 cubed equals 1,000. Okay, what about one a little harder? Make you think a little more. How about log of 0.1? What does this equal? Well, we have to think about it a little bit. All right, 0.1, can you write that as a fraction? Yeah, well, that's 1 over 10. Okay, well, can I write that as 10 to some power? And the answer is yes. The answer is -1. So what have we seen? That 0.1 is 1 over 10, which is 10 to the -1. So therefore, what is the power I raised 10 by to get 0.1? And the answer to that is -1. Okay, so you just have to wrap your head around this question. What is the power we raise 10 by to get x? And you're not going to have a problem with these things. All right, what about one more of these, little 5? How about log of square root of 10? So what is the power I raised 10 by to get the square root of 10? Well, we have to go back a little bit. Remember, square roots are really exponents in disguise. So a square root can be written as an exponent of a half. So square root of 10 is really 10 to the half. So what do I raise 10 by to get 10 raised to the half? Well, the answer is a half. These things are so simple because the answer is really built into the question sometimes. Like, what color is your blue shirt? Well, the answer to that would be blue. Okay, so let's see, a couple things to note. Get some stuff out of my way. All right, little c. A very important thing, note the x has to be positive. All right, so the input for logs we'll say the input for log of x, which is x, must be positive. And remember, we're saying positive, so 0 is not an option. It's got to be bigger than 0. Okay, so let's see. So some more notes. We'll call this little d. Logs versus exponents, or exponentials. Okay, so the whole idea is, in math, you always learn to do one thing, then you learn to undo it. We learn to add, so then we learn to subtract. We learn to multiply, and then we learn to divide. Well, here we learn to take powers and apply exponents. Now we want to learn how to undo those, and logs will help us undo that. So if y equals log of x, then 10 to the y equals x. If 10 to the y equals x, then y equals log of x. So it works both ways. So notice, here's an exponential. Here is a logarithm. So what we've learned is these are inverses because they undo one another. These are going to undo the operation of the other. Okay, so that's how we're going to start solving logarithmic equations pretty soon. All right, so let's see. So what about, we need some properties. So little e, properties of logarithms. All right, first, log of 10 raised to the n. Well, this is simply going to be equal to n. And if we think about it, that should make sense. What is the power I raised 10 by to get 10 raised to the n? Well, the answer is n. Okay, little 2. How about 10 raised to the log of n? All right, well, remember, we said a logarithm is an exponent. So log of n represents whatever power I need to raise 10 by to get n. So what happens is 10 raised to the log of n is just going to be n. All right, so what about this one? Log of a times b. Well, that one, we're just going to rewrite that as log of a plus log of b. So this should make sense. Since this represents an exponent, what happens if I'm multiplying the exponents together? That means I'm going to add the terms. Or, excuse me, if I'm multiplying the terms, that means you add the exponents. All right, what about log of a divided by b? Similarly, log of a minus log of b. Because if I'm dividing the terms, you subtract the exponents. Then little 5. This one's going to come into play a lot later. Log of b raised to the t, where t is the variable and b is some number. I can write that as t times log of b, which is very nice, and that just goes back to this equation. So remember, an exponent just means repeated multiplication. So this is log of b times b times b times b, t times. So then when I would write it like this, log of b plus log of b plus log of b plus log of b, t times, and then I can write that as a multiplication. And then little 6, the last property for now, let's see, is log of 1. And let's think about this. So this side, this log of 1 says what is the power I raised 10 by to get 1? So 10 to what power gives 1? And the answer to that is 0. So log of 1 always equals 0. Okay? So let's see. So then, this little e. So those are your properties. So little f, let's talk about the graph of y equals log of x. All right, and remember the base is still 10. So let's see. So the graph is going to look like this. Here's your x. Here's your y. And it's going to look like this. It's going to pass through 1 on the x-axis. And it's going to be asymptotic to the negative y-axis. All right, we have a domain. We already said what the domain is. Did you catch it? Remember, the domain is the set of all valid inputs. Well, we already said that the domain has to, that the inputs have to be positive. So the domain is the set of all x's such that x is positive. Or if you prefer an interval notation, 0 to infinity. The range is going to be all real numbers because we go from negative infinity to positive infinity. There is no y-intercept. The x-intercept is 1, 0. And we have a horizontal asymptote. X equals 0. Okay? So what we're going to do is, these are your notes. I'm going to come back with another lesson, which will be part 2, and that will do all. We'll have all the examples there. All right, so see you in a minute.